Well, here we are in recording 1B for our series on angles and standard position, Unit 2, Chapter 2, Trigonometry, Mathematics 2200. We'll be focusing our attention on reference angles and the relationship to angles of rotation in standard position. If you recall, an angle in standard position has its initial arm on the positive x-axis, vertex at 0, 0. We had benchmark angles at 0 degrees, 90, 180, 270, and back to 360. However, for determining reference angles, we will need to focus our attention on the 0 degree angle, the 180 degree angle, and the 360 degree angle, the ones that occur on the x-axis only. Our reference angle for an angle of rotation from standard position is formed by the terminal arm and the benchmark angle on the closest part of the x-axis. So in this case, our closest benchmark angle would be the 180, which is on the negative part of the x-axis. We've rotated 67 degrees past that benchmark to get to the 247 degree angle. So our reference angle is 67 degrees in this case. Notice the use of theta with the subscript r to help us distinguish between the reference angle for angle theta and angle theta itself. So we know that if we use theta and theta sub r, theta subscript r, theta sub r is the reference angle. Let's have a look at a demonstration to help us have a closer look at the relationship between an angle in standard position and its corresponding reference angle. We'll begin by taking a look at a point P, initially at 0, 0, or I should say at the 0 degree angle, vertex at 0, 0 for the angle, and we rotate it to a 49 degree position. So the initial arm was on the 0 degree line, terminal arm up here, and the closest part of the x-axis is the positive part of the x-axis. Closest benchmark angle is 0 degrees. So in this quadrant, our standard position angle is 49 degrees, and the reference angle happens to be the same measure. So in quadrant 1, it's always true that our standard position angle is equal to the reference. Now, I've moved the reference angle over to the second quadrant because we're going to rotate point P into quadrant 2 until we get that reference, 49 degrees. The terminal arm is right here. Closest part of the x-axis is the negative part of the x-axis. So our reference angle is formed between the terminal arm and the negative part of the x-axis. The benchmark angle there is 180 degrees. You'll notice that we have our angle from standard position is 131 degrees, and that is equal to the benchmark, 180, minus the 49 for this quadrant, because we have fallen 49 degrees short of the benchmark. So in this quadrant, it makes sense to say that the standard position angle is equal to 180 degrees minus the reference. Continuing into quadrant 3, I want a 49 degree reference again. So I'm going to rotate point P, that initial arm, until we get a 49 degree reference. Notice that we now have a standard position angle that rotates fully to 229 degrees. The closest benchmark angle on the x-axis to our terminal arm is again on the negative part of the x-axis, the 180 degree line. we have rotated 49 degrees past that. So it makes sense to say that 180 plus the 49 gives us the 229 standard position angle. To summarize that, in quadrant number 3, our standard position angle is always equal to 180 degrees plus the reference for the angle. Continuing into quadrant 4 until we get a reference of 49 again. We'll take our point P, rotate until we get that terminal arm where we have a location that gives us a reference of 49 degrees. So our standard position angle has rotated fully. You'll notice this blue arc. Okay, counterclockwise again as before, 311 degrees. We have fallen 49 degrees short of the benchmark of 360. The closest benchmark angle now is 360 to the 311, not the 0. So it makes sense that we've fallen 49 degrees short of 360, so we say 360 minus the 49, 360 minus 49 should give us the 311. You can check that. To summarize, in this quadrant, our standard position angle is always equal to 360 minus the reference. Now, the 4 examples used in the demonstration are repeated on this and the next slide for your records. To summarize, the reference angle is the angle between the terminal arm and the closest benchmark angle that lies on the x-axis. The relationship between an angle in standard position and its reference angle depends on the quadrant where the terminal arm lies. And there are 4 more examples here for you to have a look at.